So that one has more than just an in and out, right? It has a third one. And where's that third one going? Going to drain. So it's got to put water down the drain when it's making clean water. So this membrane is rated for what kind of production?
50 gallons per day.
50 gallons per day. That 50 gallons per day production is based on a couple of factors. It's based on water temperature. It's based on the inlet water TDS. What does TDS stand for?
Total dissolved.
Total dissolved solids. So how much mineral is dissolved in that water. And it's determined by the inlet pressure. And we kind of already talked about the pressure already. So I'm going to put water in at a certain temperature, a certain TDS level, and at a certain pressure. And what will that membrane produce in a day, in 24 hours? That's where that 50 gallons comes from. Those numbers are 77 degrees Fahrenheit water, and what we test to is 500 milligrams per liter, or 500 ppm is our inlet TDS level. And that's done with sodium chloride as a standard dissolved mineral. Okay? That'll produce 50 gallons per day. Oh, and by the way, it's to open atmosphere. So if I just had this open and it was letting water out, I would produce 50 gallons in a day. We already know where I'm, again, Wisconsin, Minnesota, Michigan, Illinois, water that comes out of the ground or out of the lake or whatever isn't going to be 77 degrees. It won't. It's probably going to be more in the neighborhood of, depending upon the time of year, somewhere between 45 and 55 degrees. Now,
Where you're from, or?
Yeah, 55 degree water. It's not like it's on the other side of the planet. It's just Wisconsin. 55 degree water is a lot more dense than 77 degree water. So it's like running maple syrup across the membrane versus 77 degree water, which is like water. That's the way the membrane sees it. It's a lot different operation. It doesn't take a lot of temperature swing to change production of an RO membrane, because that water denses up it's significantly different, okay? So the production rate goes down as the water temperature goes down. On the flip side, production goes up as the water temperature goes up too. You'll see some systems, especially commercial systems, where they'll have a tempering valve and they'll actually mix in a lot of little hot water with the cold water on the inlet side. You can get these up to right around 100 degrees Fahrenheit. Keep in mind, you start getting them warm, they start loosening them up. So, but you can increase production if you warm the water up a little bit too.
So from like 75 to 90 would be like perfect.
I'm not versed enough in RO to be able to tell you, Alex, exactly what the best temperature is, but that's probably a fair estimation. Somewhere a little bit warmer than 77, less than 95 degrees is kind of where you're going to get the optimum performance. Okay? Thing is though, as you start warming water up, especially if you need cold water on the backside, you're warming, it's energy. That's all energy. It's stuff now you got to chill it, you got to do stuff to it. So all that comes in when you're making a system. All those factors come in. That's why people like iFilter, they're working in areas where, okay, now you got to take all that into account. Okay? So, but you understand it. Colder water, lower production. Higher TDS, higher demand on what we're going to do, lower production. So if I'm above 500 ppm, if you're in Midland, or if you're out in Pecos where the water's 1,500, 2,000 milligrams per liter coming out of the ground, lower production. It'll still do the job. Theoretically, I could put that seawater through here at 30,000 to 60,000, and I'm going to do some rejection, and I'm going to make purer water. So what is that rejection rate? About 96 to 98% of the dissolved solids I'm going to. Okay. Now, another thing that, as far as what Phil's talking about, remember, in order to make 50 gallons per day, I'm running the atmosphere. There's no pushback, and I'm making 50 gallons per day. Well, in order to store in my tank, I know as soon as I start filling this tank and I start depressing that diaphragm, I'm already working against 6 psi of air pressure. But as this increases, that pressure increases with it. So it's going to start back pressuring that membrane as soon as it starts filling this tank. So your efficiency starts going down the fuller the tank gets, because you're getting more and more back pressure. Okay? So these are, and I'm not saying that this is stuff you lead with, but the consumers out there that start Googling and stuff, if they ask questions, it's good to know that stuff, right? It's good to, hey, transparent, you're right, that's what happens. But, and like Jay said, or at least what Jay was alluding to, but the benefit is that membrane, what we're competing against 1-to-1, is a membrane that's kind of made to go 4 or 5 down the drain to one it's making. This is 1-to-1. Back pressures, you lose some of your efficiency, and you will. You'll start running more water down the drain than you're making. But as a level comparison, it's still going to be many times more efficient than a typical